This is 9-2 translations. Start with the warm-up and hit pause while you try the problems. Hit play when you're ready to see the answer. So for the warm-up, number 1, if I'm reflecting across the x-axis, I know that the x is going to remain the same. So the x stayed the same, and the y is going to become the opposite sign. So that's what I did to get my coordinates for 1. For number 2, if I'm reflecting across the y-axis, I know the y's are going to stay the same, but the x becomes the opposite sign. And to reflect across the line y equals x, switching out the y and the x, I'm reversing it, so it goes y comma x. Okay, I added something to the definition of translation, which is a slide, because we start talking about vectors all of a sudden, so I want you to understand that a translation is a transformation along a vector, such that each segment joining a point and its image has the same length as the vector and is parallel to the vector. So this idea of a vector is thrown in here. It's really just what we've been doing all along with the translation. So I don't want you to be too thrown off by that. So if we have a translation, we would not have a rotation or a reflection. And this first one actually looks to me like a reflection. It's symmetric, so I would say no, this is not a translation, because it's not just sliding. The same points aren't in the same spot as you move. But here, like this point just drops to here, and this one is brought down to here, that point there, and this point here, and it stayed the same way otherwise, so that is a translation. It's sliding from one spot to the other. Translation is sliding the figure up, down, left, right, and so we're really just adding or subtracting along the x or the y. So if I have an x and then I'm adding something to that, that means that I'm going to be traveling to the right. And if I have an x and I'm subtracting something from that, that means that I'm going to be traveling to the left. And then we would have our y. If we have y plus something, that means we're traveling up. And if we have y minus something, then we're traveling down. So you don't necessarily need the blue table for example 3. It's there to help if you find it helpful, but basically what it is you have your pre-image coordinates, which are d is -3, -1, e is 5, -3, and f is -2, -2. And we have this vector translation, which is saying 3, -1, meaning I'm going to add 3 to the x, and I'm going to subtract 1 to the y. And so that will result in d prime. Once I add 3, that's going to be 0, and I subtract 1, I get -2. And so that's the same vector translation for each of them. And so now for e prime, 5 plus 3 is 8, and then I'm going to subtract 1 from the -3, so that's -4. And then f prime is going to be -2 plus 3, which is 1, and -2 minus 1, which is -3. And so we could take a look at how that translated on the graph. So d is -3, -1. E is 5, -3. And f is -2, -2. And then for the image coordinates, we have d prime at 0, -2. And then we have f prime at 1, -3. Oh, I forgot e prime. E is at 8, -4. 1, 2, 3, 4. Okay, so let's see what happened then. So basically we're translating So from the D to the D prime, we went down 1 and to the right 1, 2, 3. So that's a -1 on the Y and +3 on the X, which is exactly what we have in our vector translation. And so you could check that with each point to make sure. So from F to F prime, it's down 1 to the right 1, 2, 3. And for E to E prime, it's down 1 and to the right 1, 2, 3. Try that now. You try and hit play when you're ready to see the answer. So go ahead and pause the video now. Hit play when you're ready.